Thank you, Louisa. Our next speaker is Robert Berk from the Illinois State Police in Chicago, Illinois. Robert has contributed many articles to the forensic community over the years on gunshot residue. And his talk today will be on non-tox ammunition and criminal casework.
Like any other research project that I've gotten involved with, it came about because something unusual hit my desk, whether it's airbag residue or gunshot residue or whatever projects I've worked on in the past. And in this situation, early last summer, a gunshot residue kit came across my desk. The suspect had fired mixed rounds of ammunition, which is pretty typical. He had been apprehended, a gunshot residue kit was taken, and positive test results came from that kit. The ammunition was part of the information that I was given, and I was informed that, in fact, one of the rounds of ammunition that he had discharged was a S&B non-tox. Well, I'd only heard of S&B non-tox in the past. I hadn't experienced any in casework, and simply having one round of it was enough to do a little background paper research on it. But within a short period of time, a second case hit my desk, and in that situation, it was a little bit more serious. Suspect had fired at the police, had fired 5 or 6 rounds of non-tox ammunition, and police returned fire and struck the suspect. He did not leave the crime scene. His gun was recovered. The discharge cartridge cases were matched back to the gun, and sure enough, it was all non-tox ammunition. So all of a sudden, last summer became the summer of non-tox, but actually that was the last of the casework that came through. The gunshot residue kit that came from the suspect that was shot by the police came back negative. So I knew that at this point I've got to do a little bit of research because eventually I'm going to testify in this case, and I have to have that reasonable degree of scientific certainty so that I can talk about non-tox as an expert. When you're looking at typical gunshot residue analysis, you're looking at small arms percussion primers. So there's typically some sort of an initiator, an oxidizer, a fuel, a frictionator, sensitizer, and binders. And most modern American-made ammunition will have all of those components present. Typically, the formulation is referred to as Sinach. It replaced mercury fulminate back about 50 years ago due to the fact that the mercury fulminate would damage the weapon over a period of time. It would start to make the metal rust. So Sinach is a easy or loose translation, simply means without rust, and the typical composition of the components of the primer would be a lead, barium, antimony compound along with some other materials, and that was, when detonated, formed the material that gunshot residue analysts have been looking for the last 50 years. When I first started with the Chicago Police Department, we were doing bulk analysis. So I had an atomic absorption spectrometer. We were taking hand samples only. We were looking for elevated levels of the 3 elements, lead, barium, and antimony, and we were looking for them in proper proportions. If you were here earlier or yesterday when they did the case study on the rape in Switzerland and the possibility of gunshot residue being in that case, when I looked at the numbers, it didn't fall into what I consider the proper proportion. So I would not have mistaken that for gunshot residue, and then luckily enough they figured out that it wasn't gunshot residue. But for the last 15 years, we've been doing particle analysis, in which you basically are looking at the elemental composition and the morphology of the particle. You get a particle that, as you saw earlier, forms as the hot materials are cooling down into a solid. So they start off as a sphere, so they have that proper morphology, and also the elemental composition of lead, barium, and antimony, which is fairly apparent in that particle. The only time I've ever had a problem with a unusual primer, ammunition type being submitted was back when I was working for the Chicago Police in '96, and a case came across my desk. The head stamp of that ammunition was MRP. The suspect's kit came back inconclusive, and MRP is MagTech Recreational Products, and at the time there were a ammunition company in the United States. They're working out of Phoenix, Arizona, out of Las Vegas, Nevada. So we got in touch with MagTech to see exactly, I'm sorry, jumping ahead a little bit. The gunshot residue kit was inconclusive. When we took and looked at the swabbing of the cartridge case, we were able to detect lead, we were able to detect barium, but we weren't able to detect any antimony. So we contacted MagTech to see exactly what kind of priming formulation they were using, and they said that they had purchased their primers from CBC. And I'm going to give you my best Portuguese for this, but the Companhia Brasileira de Cartuchos, which is simply the Brazilian cartridge company. So we contacted them, and they informed us that from 1987 to 1995, they were making various primers for cartridge cases. Their priming mixture was 5067, which only contained barium, lead, and tetrazine. So They weren't using any antimony in their formulation. So we decided to take that a step farther. I had a couple of volunteers that were working with me at the time, and we went up in the firearms section with some of this ammunition. We simply test fired 6 different 9mm guns out of the Chicago Police Reference Collection. The individuals either fired 1 or 2 shots under ideal test conditions. All the test results came back inconclusive, and it was either a result of a lack of elements that we're looking for or simply unacceptable ratios. We went back and verified the components in the cartridges by using AA, atomic absorption, and also SEM, and found them to be antimony-free. So that brings us up to the question of today's talk, and that's the S&B non-tox. Well, S&B is cellular and below. It's a Czech cartridge manufacturer. They've been in business since the 1870s. They're promoting this as green ammunition, and there's no mistaking why they picked the color scheme for the boxes that they're selling their ammunition in. 2 different shades of green and also a shamrock down in the bottom right-hand corner. They are referring to the Sinach formulation in their literature. They said that when you discharge that type of ammunition, you discharge a large amount of toxic heavy metals, and they don't meet the environmental standards, whatever that means. But they're promoting this type of ammunition for sports, hunting, and practice shooting, and the shamrock down in the bottom right-hand corner has got 3 universal symbols for no, and inside those 3 universal symbols are the chemical symbols lead, barium, antimony, and mercury. So they're promoting it as being free of all heavy metals that basically we're looking for in gunshot residue testing. S&B does hold a U.S. patent for this formulation. It's 6964287. It's a non-toxic and non-corrosive ignition mixture. So they're using either a nitroester or a nitramine as the initiator. They're using tetrazine or a derivative of tetrazole as a sensitizer. The oxidizer, either a peroxide or oxide of metal, and their fuel is amorphous boron. So for those of you who do SEM analysis, really the only thing that we could possibly be looking for would be whatever metal they're using as a peroxide. There's 20 different formulations that they show in their patent, and each one of those is a potential that they could use in their manufacturing process. The only one that really makes any sense to me is number 14, and that lists tetrazine, penthrite, potassium nitrate, boron, nitrocellulose, and glass as the composition, because when we popped these primers over SEM sample stubs, we really didn't see anything from the primer other than some potassium. So the other ones don't make any sense. This one does make sense. I can't be sure that they're using it because it's something that they're basically not going to tell you. Well, how available are they? Well, S&B was recently purchased by CBC, so the Czech company was purchased by the Brazilian company, and they still are manufacturing a wide variety of their ammunition, so it comes in a variety of different cartridge cases. One thing that's very notable about S&B, on their head stamps, they put a red coating on it that looks like fingernail polish, and actually it is fingernail polish. It's a nitrocellulose-based component they're putting on there, and I would only assume that it's to keep it dry so that there's no moisture that creeps up into the primer cup. As far as CBC goes, MagTech Ammunition, it's all the same players. MagTech is the only company that imports CBC into the United States. So we were able to find both the 9mm and 40 Smith & Wesson online. That's how we purchased ours. We simply online purchases and had them shipped to, well, not my house because I live in Chicago and they won't send it there, but to someone else who lived in the suburbs. We weren't able to find any of the 38, we contacted MagTech to see what other, or where we could find other types of that ammunition, and they said the only other thing that they import is the 38 Special. We couldn't find that anywhere online, but MagTech was nice enough to send us a box, so we were able to do some test firings with it. Since the primer in question doesn't add to the lead, barium, and antimony that's in the weapon, that amount of residue for a given gun is going to be a specific finite amount. It won't increase as long as you're not firing any more of that Sinach type ammunition in that weapon. And you know that every time the weapon is discharged, you're going to lose a certain amount of residue from the gun that's built up from prior discharges. So as long as I'm able to put an infinite number of shots through a firearm that has a finite amount of the gunshot residue in it, eventually that gun is going to clean itself of all that residue, and from that point on, I should start seeing nothing but false positive test results when I look at gunshot residue testing. And you've got to realize that most of the time when you are doing that type of testing, you don't know what type of ammunition was discharged. You're simply looking for the generic particles that contain the lead, barium, and antimony. So initially, the test firings that we did were trying to answer the initial question of how many discharges before you start to get a false negative gunshot residue test. Later on, we realized that what we should be looking at also is how does this type of ammunition affect this sodium rhodisonate test on distance determinations, and you'll see why that became important. When you typically look at gunshot residue results, you're going to see basically 7 different particle types sorted out. The first 6 are going to be your consistent particle types. Your 7th is going to be the one that has all 3 of the elements. That's the tri-component. It's the characteristic particle that the gunshot residue analyst is looking for. That number of tri-component particles is going to be important in your investigation. If at the end of the run you look and you've got a positive number of those particles present, you can get false negative test results if none of the particles were able to be confirmed as characteristic gunshot residue particles simply by not meeting the criteria, or if you simply don't have the threshold. Some laboratories have a threshold for the number of particles you need in order to come up with positive test results. If that X equals 0, at the end of the run you have no particles by the sorting criteria that met that qualification of being a tri-component particle, the characteristic gunshot residue particle. At that point, as an analyst, I'm going to write a negative lab report and feel very confident about the fact that there's no gunshot residue present. There's nothing positive to link this individual to the discharge of a firearm. If you're doing any type of gunshot residue analysis, you should refer to ASTM E1588, which has been released last year, it's -10, gunshot residue by SEM EDX. And there, Part 7 on data analysis refers to the characteristic particles as simply being those that have lead, barium, and antimony present. And when you discharge a non-tox cartridge through a gun that has Sinach residue in it, you do in fact start to see regular-looking characteristic primer gunshot residue particles. All 3 of the elements are present and obviously present in the residue. You will meet some particles that don't, you will find some particles that don't meet that criteria, and that you can't clearly see the lead, or you can't clearly see the barium, or you can't clearly see the antimony, and I'm not going to classify that particle as being a characteristic gunshot residue particle unless it does meet the criteria. Also, when it talks about data analysis, it's also, they say that it's common for additional elements to become incorporated into the particles containing these elements, and the elements they're talking about are the lead, barium, and antimony, and potassium is the one element now that we're going to have some problems with. This is a this is a particle that was emitted from a firearm that was discharged with non-toxic ammunition, and based on the amount of potassium that I'm seeing in my spectrum, I'm not going to qualify that as a characteristic primer gunshot residue particle. What it looks like to me is that you've got a percussion primer residue in which some additional oxidizer was used, and that shows up in the form of the potassium in the particle. So that's a particle that I'm not going to classify simply because of the fact that it doesn't indicate a discharge of a firearm, because in airbag residue you can see similar particles being produced. This is a particle from a 2003 Ford van on the passenger side. They use percussion primers as part of their chemical chain. They're also using other oxidizers, and this type of particle is easily viewed. For the test firings, we tried just normal hands. We didn't wash our hands in advance to make sure they were clean. It's ideal sampling conditions. It's very thorough. When you're taking samples from your own hand, you can actually feel which areas of the hand you're missing. And you've got a very willing suspect. There's more than one story about suspects being having to be handcuffed through bars or fighting with the police in order to get the samples taken. So basically, we are the ideal sampling people because we're not fighting. What I got to stress is you need to look at the particle loss over time. If that's not coming in play with the study I'm doing, and you also have to look at environmental loss when you're dealing with actual case fire situations. I am truly running out of time, so I'll briefly go through maybe the first and the last test fire series. With the first test fire series, we used a 9mm Ruger. We fired 1 round of Synoxid and took our samples as a baseline. We fired 1 non-tox round on a daily basis. The left hand was sampled before as a background. The right hand was sampled to see what was deposited. We did see typical gunshot residue particles being deposited. We also saw these large, all I can refer to them as clusters. They were large, brittle conglomerates of particles. They were the source of sequential primer gunshot residue particles in the study. So if you look at your test results and you might have 400 characteristic particles that are being identified, there might be 200 of them in a row that have sequential numbers, and it seemed like the instrument was sitting on an area and taking a lot of samples. So that's one of the clusters. You can see it's already cracked once. I think once it gets stuck to the tape and gets dabbed again and again and again, they tend to break open. So this is another cluster that's breaking open, and then finally it ends up basically as a debris field, and the instrument just goes crazy because it sees all those as individual particles of gunshot residue. Anyhow, I thought we'd walk into this and do 5 or 6 shots and be done. With the 9mm that we first started out with, after 47 shots, we're still well into the positive range, and that's just the particles that the instrument's detecting. We're also, when we go back and verify the particles, we're also still seeing huge numbers of positive test results, and as a result, the gun really isn't cleaning itself out. One thing we're seeing, one thing my lab does is look at consistent particles, which is the load factor, which is the number of consistent particles over a given area. And anything that's above what we consider to be elevated and significant is just basically a red flag. So for most of those test firings, we're still seeing load values that are elevated and significant and give me an indication that something isn't actually going on. One of the reasons for that high load factor is it seemed like the number of lead particles was increasing. Well, that didn't make any sense at all. We had popped primers before. We looked at the composition. You see a brass primer cup. You see nickel anvil. We looked at the smokeless powder. It's the typical double-base nitrocellulose, but when we took a look at it under the SEM, we could see that there was an additional coating on it, which turned out to be potassium. So they're putting an extra oxidizer onto the smokeless powder. And then if you take a look at that very small particle, what we're seeing is lead. They're putting lead into their smokeless powder, most likely as a barrel lubricant. Well, their advertising is lead, barium, and antimony free, but they're putting lead into their smokeless powder, so it just simply didn't make any sense to us. But that was the reason that we would see the increase in the lead particles on our hands, and also the single shots simply seemed to be gumming the gun up. So what we did was we got away from that type of testing and went into multiple shots being fired. 1 round of Sinach through the gun. I had him clean it as best as possible. I fired 1 non-tox round as a baseline and continued to do non-tox firing on a daily basis. With that, you are seeing the exponential decay of the particles being detected, but after 47 shots, we're still seeing positive test results. The verified particles are still positive. The load values are still significant, but you can see the number of lead particles is decreasing. We were running out of 38 special ammunition, and we weren't going to get any more, and that's not 39 special, it is 38 special. So what we ended up doing was taking a look at distance determination. There was an article that was published by the Germans, Brendis, and others from the BKA. They talked about non-tox ammunition. They talked about the reason that they were doing this is because of lead-free ammunition, and sure enough, you can only see the potassium when you fire these in the close range. They wanted to take the place of the sodium rhodisonate test that was, if you need a reference, Dylan from the FBI had that, and he talked about positive test results primarily due to lead composition of the primer or for barrel interaction. So this is 2 distance determinations that I did with Synoxid ammunition and fired the 357 at close range, and the target is 3 inches away. You can see the heavy soot build up. You can, if you look at it microscopically, you can see particles of smokeless powder, partially burnt, that are in place. When you treat it with the chemicals, which is the slide on the right, you can see the bright color you're getting from the positive reaction for vaporous lead. When we fired into our test shots using this non-tox ammunition at 6, 12, and 18 inches, we didn't see any soot at all. Microscopically looking at the targets, we didn't see any smokeless powder. Testing the 6-inch one, we skipped the modified Grice test because I didn't want to interfere with the minor amount of lead that might be deposited. We just barely got a positive test result for the vaporous lead. So with that, no visible soot, no partially burnt smokeless powder, and atypical vaporous lead results, that's not going to screw up your firearms examiner because he's going to have the actual gun in question and he's going to have similar ammunition. But what this comes in as a problem is for your medical examiner, who may simply look to see is there any stippling and is there any soot on a close contact wound to identify it as such. And without that smokeless powder going down range, you don't get the punctate abrasions that the medical examiner will call a stippling mark. So we don't have the ability to shoot into any living suspect to see if this actually were the case, but we would assume that there would not be stippling and that the medical examiner may have problems with it. Then very quickly, I just want to talk about the last series of test firings. We took a very clean 9mm. I had assistants fire 150 rounds down at an outdoor range. Then we brought it back in the lab and fired it later on. The 151st shot was still positive. I'm going to skip on to the next shot. The 161st shot, so in between we had 9 shots fired. Finally, on the 171st shot, we got no tri-component particles identified by the instrument, no tri-component particles identified by the examiner in verification. We went ahead to see if the gun was truly clean and would repeat that, and sure enough, that's not the case. For 172, it was positive. For 181, it's right close to positive, and for 191, it's still in the positive range. We're going to continue on with this test firing along with a couple others that I skipped over because of a lack of time. But basically, you can see from this situation, in a real shooting case where somebody discharges a firearm and you only have 5, 6, or 7 tri-component particles, that's immediately after the samples are taken. And the situation would be that they would lose particles over time, and chances are those individuals would have false positive test results. And that's basically what my conclusions are. Distance determinations might be problematic. Positive results are possible. False negatives are more likely, and it's difficult to remove the memory effect from the weapons. And very quickly, to thank my sponsors, the Forensic Science Command and their research and development laboratory allowed me to do it and basically paid for most of the ammunition. Mark Pomerantz, firearms examiner, helped me out significantly with this test firing. I did have Radson as a summer intern. Scott Rockwitz did some test firings. Kellen Hunter did help me with the distance determination, and MagTech sent the ammunition. But thank you for your time.